Well, hello there. Mr. Sutton bringing you the BC Calculus 7-3 Extra Practice number 5 solutions on transformations of Maclaurin series. For this problem, we want the Maclaurin series for x cosine of x squared. Well, let's start with the cosine of x Maclaurin series. That's going to be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And we could keep going. I'll do one more. Minus x to the 6th over 6 factorial. Don't need to go beyond that. So next thing I need to do, I have two transformations. I need to replace the x in here with x squared. And then I need to multiply afterwards by x on the outside. Let me do the x squared first. So essentially replacing all the x's in the original series with x squareds. So this will be still a 1 in the beginning. But now we have x squared squared. So that's x to the 4th. And we still have that 2 factorial down there. Next, we have x squared to the 4th, so that's x to the 8th over 4 factorial being added there. Minus x squared to the 6th is going to be x to the 12th over 6 factorial. All we have to do now is multiply that by x to get x cosine of x squared. So distributing the x to everywhere, we're going to have an x in the beginning now, minus x to the 5th over 2 factorial. Plus x to the 9th over 4 factorial, minus finally x to the 13th over 6 factorial. And looking at my answer choices, let's see, we're starting with an x, so it's going to be a or b, and minus x to the 5th over 2 factorial, that's going to be choice A, and the rest of it matches up as well, so choice A. For this problem, we want the 4th degree Taylor polynomial for x times sine of x at x equals 0. So basically Maclaurin series for x sine of x. Let's start with Maclaurin series for just sine of x. That's going to be just x minus x cubed over 3 factorial. And I would write plus x to the 5th over 5 factorial. But if they only want a 4th degree Taylor polynomial, we're probably not going to have to go out to the 5th power. We will if we need to, but let's just stick with these two terms for now. So next thing, we need to rewrite this. We need to transform it into x times sine of x. So to do that, I'm essentially just taking these terms and multiplying them all by x. So we have x times x, which is x squared, minus this will now be x to the 4th over 3 factorial. And actually, hey, we're done. We've got a 4th degree polynomial here. So we're just going to chop this off at the x to the 4th term and see if we can find this in the answer choices. So I need to start with a positive x squared. That actually immediately eliminates all but choice C. The other term in choice C, we have a 1 over 6 x to the 4th, and 3 factorial is 6. So this does work out, so choice C then. For this problem, they want the approximation for cosine of 1/2 using a 4th degree Taylor polynomial for cosine about x equals 0. So we're just doing a Maclaurin series here. The Maclaurin series for cosine, this is one of those you should have memorized. This is just going to be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, and so on and so forth. But they only want a 4th degree approximation of all this, so we're just going to stop here. And now we're just going to plug 1/2 into all of this. Now when I do this, I mean, you could think of this second term as really being x squared times 1 over 2 factorial. And this is x to the 4th times 1 over 4 factorial. So I'm going to plug in 1/2 using that setup. So 1 minus 1/2 squared times 1 over 2 factorial plus 1/2 to the 4th times 1 over 4 factorial. Just to make it a little bit easier to do the arithmetic and not have to worry about a fraction within a fraction. At this point, it's time to simplify this because all the answers are simplified. So 1 is playing itself in this motion picture. And then we've got, let's see here, this is going to be minus 1/4 times 1/2. So that's going to be minus 1/8. And at this point, we've got it narrowed down to answer choices A and B. C and D, they had a 1 minus 1/4, so that can't be the answer. So it's either going to be a plus 1 over 64 or a plus 1 over 384 for that last term. Now looking at this last term, this is a little bit of a beast. You have 1 over 2 to the 4th basically, so 1/16 times 1 over, this is, let's see, 4 times 6 is going to come out to 24. I don't know what 1/16 times 1/24 is. I mean, I could certainly do a little multiplication by hand, but let's just look at the answer choices. I'm going to guess that 1/16 times 1/24 is not 64, because 1/16 times 1/4 is 64. I'm going to guess that that stuff should come out to 1/384. And it does, if you do actually multiply it out by hand. So let's go with answer choice B. For this problem, we're given the first 6 non-zero terms of a Maclaurin series for some f function right here. We want to know which could be an expression for f of x. So this is one of those where you basically have to start trying different answer choices to see which one works. It's kind of a reverse engineer sort of problem. Now, if you look at all these answer choices, the good news is these all contain series that we know or could quickly find. This e to the negative x, this is based on e to the x, which we know is going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial, and we'll go one more, plus x to the 5th over 5 factorial. Why did I go all the way out to 5? Well, I mean, if you look at the Maclaurin series they gave us, it also goes out to 5th power. So I just want to have more to work with here. Now, we also have sine of x and cosine of x. So let me quickly write those out. Cosine of x, that Maclaurin series, is just 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And I'm pretty confident I don't need to go much further, since the next term would be an x to the 6th, and this only goes out to x to the 5th. Now for sine, that's going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and we'll stop there for that one. Now we're just going to transform these answer choices, or transform these functions to get me these answer choices, and I'll just keep doing that until I have something that matches this answer here. So e to the negative x, let's start there. I'm basically just plugging negative x into the e series. So I have a 1 minus x, and then we could keep going, but if you look at this Maclaurin series they gave us, it was 1 plus x. So already on this second term, there's no way this is going to work out to what we want. So I'm just going to call that a no and keep moving. So now we have cosine plus sine. So basically just combining like terms, except that there aren't any. So just taking the terms one at a time here. We've got a 1 that doesn't have anything to combine with it, plus this x has nothing that goes with it. So far that matches. That's a good thing. And then we have a minus x squared over 2 factorial, minus x cubed over 3 factorial would be the next term, plus x to the 4th over 4 factorial, plus x to the 5th over 5 factorial. And it keeps going, but that's as much of the series as they gave us here anyway. So far this is looking like it works. We haven't contradicted this original. Just to be on the safe side though, let's test out these other two. This will be pretty quick. So cosine minus sine of x. So we're going to start with a cosine series, which is 1. And now we're subtracting all the terms of the sine series. So the next term is going to be a minus x here. And that already is not what we had for the original, so that's a no. For this next one, we have sine minus cosine of x. So if we're subtracting cosine of x, that's going to be a negative 1 to begin with, and a positive x. So that's already bad news. This one fails on the very first term. Wow, that's an epic fail. So at the end of it then, we've confirmed it. Choice B is the best answer. On this problem, I'm trying to figure out what this big gnarly series with pi's and factorials and exponents comes out to. So the key on this one is pattern recognition. You notice that we have an alternating series. We've got these factorials down here. These are all the even factorials. So maybe just in the back of my mind, I'm thinking maybe there's a cosine or a sine involved somehow in all of this. Now, one of the things that's holding me up is that the exponent in each of these terms does not match the factorial, but it's 1 off from the factorial. If you look really closely now, you'll notice all these terms have a pi in them. So maybe I could fix this exponent factorial mismatch issue by factoring a pi out of everything. Let me try it. So if I take a pi out, our first term is now going to be 1, which a lot of Maclaurin series actually begin with, so this is good. Then we have minus pi squared over 2 factorial, plus pi to the 4th over 4 factorial, and that pattern just keeps going. So you might recognize here that this is the pattern for cosine. This is the Maclaurin series for cosine, basically with pi instead of x plugged in. So what we're essentially dealing with then, this is really just pi times the cosine of pi. Well, cosine of pi is just -1, so this is just cosine pi times -1, which comes out to negative pi, which gives me answer choice A. For this one, we want the coefficient of x to the 99th in the Maclaurin series, e to the x minus e to the negative x. All right, so you could start writing out the Maclaurin series for e to the x. I mean, we know it. It's 1 plus x squared over 2 factorial plus x to the 3rd over 3 factorial. And we could keep going. But the general pattern is eventually, you're going to get out to the x to the 99th. And hopefully you didn't actually write all that out. Hopefully you saw the pattern and recognized that at some point we have an x to the 99th over 99 factorial with a whole bunch of other terms where the exponent and the factorial match. Now, e to the negative x is basically e to the x, but we have a negative x plugged in for all the x's. So all that's going to change by the time you get out to this term with e to the negative x is that since you have an odd exponent, this whole fraction is going to come out negative instead of positive. But that's really the only difference. So to get the coefficient of x to the 99th for e to the x minus e to the negative x, well, if we were to do e to the x minus e to the negative x, you've got to combine like terms. So we have x to the 99th over 99 factorial minus this term here in the e to the negative x expression. Well, minus is actually going to give us a plus. So that ends up being positive 2 over 99 factorial times x to the 99th. So then our coefficient is 2 over 99 factorial, giving us answer choice C. On this problem, they want a series to represent the derivative of x times cosine of x squared. So the key on this one is figuring out a series to represent just cosine of x and then applying a whole bunch of transformations to it. So let's start with just the series for cosine of x. That's going to be -1 to the n, like all of these have in it, times, now this is where you have to remember what cosine actually looks like. Remember we had 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. So you had all the evens for the exponents and the factorials. So that means we have to have an x to the 2n, and we have a 2n factorial downstairs. So there's the 1 over 2n factorial. I'll just put that outside as a coefficient. And then we're going to have, because they did x separately here instead of in a fraction, I'm going to have x to the 2n. So this is the general term of the cosine of x Maclaurin series. Now a few transformations we're going to do. First we have this x squared. We have to take care of stuff inside the cosine function before anything else. So cosine of x squared is basically going to be all of this with x squared plugged in for x. Well, if I have x squared to the 2n, multiplying those exponents is just going to give me x to the 4n. So everything else is exactly the same, but now I have x to the 4n. Next transformation, let's take care of this x here, because that's the next thing in terms of PEMDAS. This derivative happens last. So we have x cosine of x squared. Well, pretty much nothing changes except that you're multiplying x by another x. So this is going to be x to the 4n plus 1, just using our exponent rules. Finally, taking the derivative of all that, nothing's going to change with the coefficient except that we're going to multiply it by the exponent. So we have a 4n plus 1 over 2n factorial for the coefficient, and then we're just going to have x to the 4n period because, well, we subtracted that 1 away. So there's our derivative just using the power rule on what we had here, and that is going to be, let's see here, 4n plus 1 over 2n factorial, x to the 4n. That's choice B. For this one, f is defined by this power series right here, and g of x is defined as this really crazy power series that has an f in there somewhere. We want to find g of 1. So this is one of those problems where you have to do a series of transformations. We know what f looks like, at least as the general term, and we need to get the general term of g of 1. So to do this, let's first do f of 3t, see how that affects the general term. So all we're doing here is we're replacing x with 3x, basically. Or actually, let me make it 3t. So we're still going to have an n plus 3 over n factorial, but now we're going to have a 3 to the n times a t to the n. I'm just going to split that up. And I think it's a good idea to split it up because then we can affect the t just individually without worrying about lumping in this 3. Next thing we have to do here, and this is already going to pay off now, notice we have a t squared times f of 3t. Well, if I have a t squared getting thrown in, I'm basically just multiplying all this stuff by t squared. So I still have all this stuff out in front. The only thing that changes now, we have t to the n times t to the second, so that's going to be t to the n plus 2. Everything else is the same. We just affected the t term with the exponent. Next, we're taking the antiderivative, the integral of all this stuff. So g of x then, just as a general function, we're still going to have n plus 3 over n factorial. We have 3 to the n, but now this gets bumped up to an n plus 3 here, and we're going to divide by n plus 3. And while we're at it, we're going to replace t with x. We can clean this up a little bit. N plus 3 over itself, that's going to cancel. So this is really 3 to the n over n factorial times x to the n plus 3. And at this point, we need to do g of 1. So if I plug 1 into all this, really I'm just plugging 1 in for x. So 1 to the n plus 3 is just going to be 1, so we don't have to bother writing it because it's being multiplied by something else. So all that's left over then is just 3 to the n over n factorial, and that's going to match answer choice C. For this one, we're defining f of x as the sine of x squared, and we just want the first 4 non-zero terms of the Taylor series for f prime, so the derivative of f about x equals 0. So basically Maclaurin series for f prime of this stuff here. Probably the easiest way to do this is just to start with the series of sine of x, the Maclaurin series, which we have memorized, and just do a couple transformations on it. So sine of x, that's just going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. And we'll go one more term since there's 4 terms in all of these answer choices. So minus x to the 7th over 7 factorial. Now, one interesting thing to note about the answer choices, if you're looking to save a little time here, is the very first term in all the answer choices is different. So really, if you just nail the first term, you can pick one of these answer choices pretty quickly. But I'll do all 4 just because I'm having fun applying these transformations. So let's do sine of x squared next. Basically just plugging x squared in for all these x's. So x is now an x squared. This is going to be minus x squared cubed, which is x to the 6th over 3 factorial. And then we have plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial. Finally, we're taking the derivative of all that. So this is f prime of x now. So we're just going to use the power rule from left to right here. So x squared becomes 2x. And immediately, if you were looking to save any time on this problem, you would say, hey, choice B is 2x, and that's the only one, so choice B. But let's keep going. So we've got, let's see, this next one, this is going to be 6x to the 5th over 3 factorial that we're subtracting. And then we have 10x to the 9th over 5 factorial, and 14x to the 13th over 7 factorial, subtracting that one. So yeah, if you look at choice B, everything after that first term is also going to match. So yeah, I think it's choice B.